Welcome back. In this video, we're going to look at the Colorado Plateau. This is the Grand Canyon, the most famous site at the Colorado Plateau. And the Colorado Plateau formed when the Kula and Farallon Pacific plates slid under the North American plate at a shallow angle and uplifted the western region of the United States, including the Colorado Plateau, which is to the west of the Rocky Mountains. And the Colorado Plateau extends across 4 states and 3 eras. The lowest part, or the lowest strata in the Colorado Plateau are at the Grand Canyon, which begin in the Cambrian, Paleozoic. Then the Paleozoic is what is seen from the bottom to the top of the Grand Canyon. And then it extends all the way up to Bryce Canyon National Park, which is in the Cenozoic era, and the top is like 30 million years old. So we have here the Grand Canyon, and then a few other sites that we'll be talking about in this chapter in more detail are Petrified Forest National Park, which has Triassic fossils, and Dinosaur National Monument up here, which has Jurassic and Cretaceous fossils, and also the Grand Staircase, which extends up from the Grand Canyon up through Bryce Canyon and so on, where there's a series of steps or mesas. So the Colorado Plateau region was near sea level during the Mesozoic, and so the coastline changed. So the formations might not be consistent across the entire plateau because one part might have been submerged under the ocean for a period of time and another part not. Here's the region of the Colorado Plateau. So you can imagine if the sea incurred over to here, then the entire plateau would be underwater. But if it was maybe here, then one part might be underwater and one part not. So scientists can look at the different formations. For example, limestone forms in shallow seas, and sandstone either is formed by sand deposited from the air or water bodies. And so they can tell exactly what the topography was at each period of time. So here's the Paleozoic formations in the Grand Canyon. We start with the Cambrian period down here, and then the Silurian and Devonian are missing. That was a period of erosion rather than deposition. So this was all lowland, and then either river sediments or ocean sediments were being deposited. And then here you have the red wall limestone, which formed in the Carboniferous, as did the Mauve limestone. And then at the top you have the Permian. So scientists can see exactly what the topography was like at each period based on the fossils and geologic materials deposited. So here's the Grand Canyon. I mentioned the Cambrian at the bottom. That'd be the Cambrian Tonto group. And we have the Coconino sandstone. And actually, this is not the Coconino sandstone. This is the Tapete sandstone. This is the Coconino sandstone right here, this light area. This is the Tapete sandstone, which formed in the sea. This formed in sand dunes. Then we have limestones. The Mississippian red wall limestone, Mississippian and Pennsylvanian are part of the Carboniferous period. And then we have the Permian Kaibab limestone at the top. So here's the Tapete sandstone at the bottom of the Grand Canyon, and it's called a delta front sandstone. There are early Cambrian trace fossils in this formation. Then we have the Coconino sandstone, which is up here near the top of the Grand Canyon. And it actually extends, and a lot of the layers do, they extend into other parts of the Colorado Plateau. So this formed in a time when the region was sand dunes and sand settled out of the air. And so here you can see the this tilt here represents the angle of the sand dune at the time. So this is a different location in Utah, Muddy Creek, that's going through this layer. And here we have the Coconino sandstone at the top of the Grand Canyon. Okay, and then the limestones that I mentioned, such as the Mississippian red wall limestone, the Permian Kaibab limestone, those formed in shallow seas. This would be a limestone forming environment, such as a coral reef, because invertebrate shells are formed from calcium carbonate. And then as they decay, they form limestone. That's what limestone's made of. That's the only way that limestone forms. It doesn't form in, let's say, floods. And also, calcium carbonate can slowly seep out of the water and also form limestone. The reason the Mississippian red wall limestone is red is just because iron has stained the outside of it, iron that seeped down from above. If you dug in, it would be white. Then the Colorado Plateau extends far from the Grand Canyon upward. So the Grand Canyon is Paleozoic, and then it starts extending into the Mesozoic. And so these are one of what are called the steps in the Grand Canyon, or the Grand Staircase. And so they form a series of mesas. So these are cliff forming units. And one of the formations we'll be focusing on with respect to crocodile fossils is the Chinle Formation at Petrified Forest National Monument. Here, it's at the Vermilion Cliffs, far from Petrified Forest National Monument. So here's this series of cliffs that formed, and here's the Vermilion Cliffs that we just looked at down here. Then you have the white cliffs, gray cliffs, straight cliffs. So these are all what are called cliff forming units, meaning they don't erode very easily, and so they stand up as cliffs. And here you can see the different formations that extend across the Colorado Plateau. Many of them are sandstones, but you also have some limestones, such as the Pink Cliffs at the top. That's what forms Bryce Canyon National Park. So scientists have tracked these formations across the park. And so here we have the Tonto group at the bottom. Remember I mentioned the Tapete sandstone in the Cambrian period. And then here's the Kaibab limestone at the top of the Grand Canyon. Then you can see that the Kaibab extends over here to Zion National Park, but doesn't extend over to Canyonlands National Park because that was probably not submerged under the sea, so it would be, I think, a sandstone. But you can see as you go to the different national parks, different parts of the formations are exposed, but there's a continuity across, for instance, Entrada Sandstone, Entrada Sandstone, Entrada Sandstone. One of the most important formations we're going to look at is the Morrison Formation, which is where Dinosaur National Monument is. So I mentioned how the Kaibab limestone extends into Zion National Park. Here's Zion Canyon, where in the Grand Canyon, the Kaibab limestone is at the bottom, but in Zion Canyon, or at the top, but in Zion Canyon, it's at the bottom of the canyon. And then I mentioned that it didn't extend over to Canyonlands National Park. Here's the Cutler Formation at the in Canyonlands National Park, and it's a sandstone. So this was a location that wasn't a limestone, but it was either near the ocean or at the very, near the beach, or a place that sandstone would be deposited in the water as maybe the water slowed down. See you next time.